It's Monday, and today we're talking about univariate data. I went ahead and split this lesson into 2 days. That way you'd have 2 shorter days instead of one terribly crammed day. Today we're just going to be defining some vocab words, and I'll show you how to actually do that statistical analysis on the Smart Calculator. So I'll be using the calculator emulator on your computer. So if you haven't downloaded that, you need to do so today. All right, so univariate data, uni meaning one, variate meaning variable. This is literally just one variable. So I'll be talking about how tall you are, how many ice cream cones you eat, test score average. Those things may or may not relate. I really don't care. I'm just looking at one piece of data. You got a 70. I don't care about what else. We will be talking about bivariate data in a couple days, and that will take 2 pieces of data and relate those 2 things together. So study time and then test grade and seeing how those things relate. But for today, we're just saying you studied 40 minutes and I don't really care what the outcome is. Okay, so you can read all this on your own. I just left it there just because I want to talk about the univariate data. But we are going to go ahead and talk about our vocabulary words. So these should be all familiar. Mean, median, mode are pretty, hopefully familiar. Mean is just the average. Add them all up, divide by the number of terms. That's your mean. Okay, and on the calculator, it's going to be called X bar. All right, median is just finding the middle value when they're all in order. If you happen to have an odd number of items, so it's going to be just the one in the middle. So median's pretty easy when it's odd. If there happens to be an even number of items or values, then there'll be 2 values in the middle, and then we'll just average those 2 values, and your median is directly in the middle of those 2 things. All right, and then mode is just most often. You could have no mode or more than one mode. All right, these down here might be a little more unfamiliar. Hopefully this is completely new. But range, hopefully you've seen range before, but range is literally just taking the max minus the min. It's just telling you literally the range of the data, max minus min. It tells you very little about how it's actually distributed. You could have the highest number be 100, the lowest number be a 0, and all your data points in between are a 7. It doesn't tell you at all about the middle, just the max and the min. However, the interquartile range does give you kind of a better idea. What the interquartile range does is you have your max and your min, and it basically cuts your data into 4 little parts. And so then you have a Q3, and we'll talk about this more when we do box and whisker plots, but you're taking the middle of the lower half and the middle of the upper half, and you're finding the range between those 2. You're finding the range of the middle half of the data. That does give you kind of a little better idea about how spread out it is, but still it's not going to tell you perfectly how it's spread out. All right, and then last thing, just definition-wise is standard deviation. This is a whole can of worms. You're going to learn a whole bunch about standard deviation when you take stats, hopefully somewhere along the way. But for the most part, just the baby definition is how much variation or dispersion your data has from the average. So taking an example that has a pretty common average, 9 months for child carrying, pregnancy is the word, 9 months for pregnancy. So most people carry their babies for 9 months. Some people carry their babies for a little longer, not in America, but other countries, because we make people induce labor. Or you might have your baby a little early. But the vast majority of people that have babies have them within that 9-month range. So standard deviation says, I want to encompass all the data. So I want to get people who have their baby in there for a very long time or people who have their baby pretty early. And so standard deviation is how many steps away from the average it takes to basically encompass all of my data. So if your data is very spread out, you're going to have bigger steps to get there. So you'll have a higher standard deviation. If your data is very squished together, kind of like this tall one is here, then you would not have a very high standard deviation. You'd have much smaller steps to get out to the edge of your data. So the higher your standard deviation, the more spread out your data is. The lower your standard deviation, the more closely packed that data is to that average. And generally, and there is a very specific numbers, you'll learn that in stats, but generally 3 deviations away is how long it takes, how many steps away it takes from the average. There actually is a very mathematical formula, which I've done this by hand, back when I was in school, we walked uphill both ways in the snow. But I'm going to show you how to calculate that in the calculator. Super duper easy. All this stuff today is actually quite easy. But in the end, just know that standard deviation, the higher the number, the more spread out, the smaller the number, the closer together that data is. All right, so we're just going to do one example because if you need to see the example again, you just rewind and watch it again. So we have Jessica. She found the heights of her classmates. Results are shown in the table. Find the mean, median, mode, range, all that jazz here. Okay, so I'm going to show you how to do this on the calculator. So if you already have it downloaded, cool. If you have an at-home calculator, cool, follow along, or at least just follow closely so you know what I'm doing. Okay, so here are your data points to the side. Also, hopefully you guys have noticed I got a new document camera, so the quality is quite nice. All right, I'm going to go ahead and minimize this guy and go over here to the calculator. All right, so on the calculator, make sure your RAM is cleared. If you don't know how to do that, on the top it has an actions button. You can just press clear RAM or whatever, or just you can do everything you do on the calculator. Second plus 7, 1, 2, and you can do all the same stuff you do on a regular calculator. Okay, so I'm going to go through it one time. If you need to watch it again, just rewind it. All right, you're going to go to Stat. So I'm going to press Stat, and it's already ready to go to Edit. So just press Edit, press Enter. And then L1, we only have one piece of data, so I'm just going to go over here and steal my data points and literally just type them in. So I'm going to go, I'm going to go type them in. You can use your keyboard or you can type them in using numbers. So the first one is 61, press enter, but I'm going to go ahead and type them in on my keyboard. So 58, 62, 60, 57, 67, 68, 61, 64, and 70. Definitely double check your data. Double check. Looks good. All right. So I'm going to go over here. So I've got 10 data points, and I'm going to go over here and I'm going to calculate. So I'm going to go back to Stat, and I want to go over to Calculate. So I'm just going to press the over arrow to go to Calculate. And we are doing one var stats, univariate statistics. We will do other stuff later, but for now we're literally doing this. You're just going to press enter. It's already going to have L1 listed for you. We don't care about what that thing means. We're going to go down to calculate, press enter, and you're done. Everything's on the screen. You just got to go find it. All right, so X bar is your average. So I'm going to go over here, and X bar is my average. So that was, I already forgot what it was, 62.8. So I'm going to type in, I'm going to write down 62.8. That is my average. Okay, next is median. So I'm going to go over to median. To get to the median, I'm going to press the down arrow key. It's got to go all the way down to the bottom, and the bottom has what's called your 5-number summary. The minimum, the Q1, the median, the Q3, and the max. And we'll talk more about that when we do box and whisker plots. But this is the highest, lowest, the middle. It's cutting your data into 4 sections, kind of like I drew the little picture. All right, the median is 61.5. So I'm going to write that guy down, 61.5. Okay, the next one is mode, and there's actually nothing on the calculator that says mode. You just got to go look at it yourself. So looking through, 61 is repeated, 58, not repeated, not repeated, not repeated, boom, boom, boom. All those guys are unique except for 61. So my mode is 61. Oopsie. My range is going to be my max value minus my min value. So I'm going to go back to the computer. My max and my min are right here. So max X is 70, min X is 57. So 70 minus 57. My range is 13. Okay, my interquartile range comes from Q3 minus Q1. So I'm going to go back over there. I'm going to find my Q3, which is 67, minus my Q1, which is 60. So my interquartile range is 7. And then the last one is standard deviation. And I'm not a huge fan of these being in this order because standard deviation is actually on the top. So we're going to scroll. Actually, on this calculator, it's right there. So normally to scroll back up on, if you're using your own calculator, there's a couple more options in here, but it's just this SX. So S lowercase x. So that's going to be 4.34. So standard deviation is 4.34. Now what that means, so this question says, what does the standard deviation mean in this case? That means that 4.34 units away from average. That means I'm going to have some average and I'm going to take a couple steps away, and I should take usually 3-ish steps, but it's going to be about 4.34 steps away in order to get all that data encompassed. And it's not an exact definition, that's also a terrible picture, but it's a pretty small number, so it means that the data is pretty close together. I mean, my highest was 70, my lowest is 57, so the data is pretty close together, so you don't really need that much of a jump to get from the average to the high or to the low. Okay, and our last question here is, which of the data distributions has the greater standard deviation, and how do you know? And again, just definitionally know that the more spread out the data is, the higher the standard deviation. The closer together the data is, the lower the standard deviation. Here is roughly the average, and I don't need to take very large steps to get to the end of my data, the max and the min. Here is roughly my average. I do need to take larger steps to get to the end. So which one has the greater standard deviation? Well, that's going to be the one that is more spread out. So that will be distribution B. And then how do I know? My answer would just be the data is more spread out. All right, so that's it for today. If I went too fast on the calculator stuff, just go back. Also, I posted several videos on the extra resources page. So if you need extra practice, you can just go there, and my B was out of the thing there, but you can just go there and use extra practice. And also, there's really not much practice I can give you today, so your homework is just a few short problems. I mean, just be able to do this because, I mean, you're going to be able to do this. You're going to need to do this in the future. You're definitely going to be taking stats at some point in time, so you got to be able to do it in a calculator. All right, have a great day. See you guys later.